So, large language models, or LLMs, they've completely exploded, right? They're everywhere, in our search engines, our phones, our jobs. But for all their incredible power, there's this major problem hiding just beneath the surface that can make them, well, surprisingly unreliable. Let's kick things off with a perfect and honestly kind of funny example.
All right, check this out. This is a real answer from a major AI model. And at first glance, it sounds totally plausible, right? The grammar is perfect. But it's just completely wrong. Tomatoes are not a good source of calcium. This is what the experts call an AI hallucination. And believe me, it is a huge, huge issue.
And that really gets to the heart of the matter for us today. If these AI models are so smart, why are they so good at confidently making stuff up? The answer to that question reveals the single biggest weakness of most standard LLMs out there. So, to really get why the solution works, we first have to understand the problem. Think of a standard LLM as a genius who's locked in a room. They have all this knowledge from their training, but they have no access to a library, no internet, nothing. All their answers come purely from memory.
This really boils down to two critical flaws. First up, you've got those hallucinations we just talked about. See, an LLM's main job isn't to be truthful. It's to predict the next most likely word in a sentence. So it can easily build sentences that sound correct, but are factually nonsense. And second, their knowledge is frozen in time. They have a hard cutoff date, which means they have no idea about anything that's happened in the world since their training ended.
So what you end up with is this incredibly creative tool that can write a beautiful poem, but it can't tell you something simple, like who won the big game last week. And for any serious business use, that disconnect from reality is a massive risk.
And this is exactly where our main topic, RAG, enters the picture. RAG is the technology specifically designed to fix this problem by giving the AI a direct line to real, verifiable information. And it's like a knowledge booster shot for the AI.
So RAG stands for Retrieval-Augmented Generation. And honestly, the name says it all. Instead of just guessing based on its old training data, this system first retrieves relevant facts from a trusted external source. Think your company's internal documents or a live news feed. Then it uses those facts to augment its answer, grounding it in the real world.
Probably the easiest way to think about this is the open book exam analogy. A standard LLM is like a brilliant student trying to pass a test purely from memory. Super impressive, but they're bound to get some things wrong. A RAG system is that same brilliant student, but now you've given them the textbook. They can look up the facts before they write down the answer.
Okay, so how does this open book exam actually work behind the scenes? What are the mechanics? Well, it's a surprisingly simple and elegant three-step process.
All right, let's walk through it. First, you take all your trusted knowledge, all your company policies, your product specs, whatever it is, and you index it. This basically turns all that text into a special, searchable library for the AI. Then, step 2, when you ask a question, the system searches that library for the most relevant pieces of info. And finally, step 3, it bundles your original question together with the facts it just found and sends the whole package to the LLM. Now the AI is everything it needs to give you an answer that's actually based on facts.
And this is why it's such a game changer for businesses. Without RAG, a customer service bot could just invent a return policy on the spot, potentially costing the company a fortune. But with RAG, that bot is forced to look up the company's actual return policy and use that in its answer. It replaces dangerous guesswork with verifiable facts.
Now, RAG is incredibly powerful, but let's be real, it's not a magic bullet. It's not like you can just plug it in and it works perfectly every time. Getting that retrieval step just right actually has its own set of pretty tricky challenges. It turns out, even when you give the AI an open book, things can still go wrong in a few key ways. The biggest problem by far is missed retrieval, which is just a fancy way of saying the system couldn't even find the right page in the book. The other two, lost in context and failed extraction, are about what happens when it finds the right page but still messes up the answer. So, let's quickly break those down. Missed retrieval is a search problem, plain and simple. The answer is in your documents, but the system just couldn't find it. Lost in context happens when the system finds the right info, but it also finds a bunch of other junk, and the real answer gets buried in all that noise. And failed extraction. This one is probably the most frustrating. The answer is literally right there, staring the model in the face, but it still fails to pull it out correctly. Maybe because the wording is tricky or there's other conflicting info nearby. So, how do we get around these problems? Well,
This is where the engineers and developers are getting really, really clever. It turns out a big part of the solution is just getting better at asking the AI to think about the problem in a more structured way.
This whole field is often called prompt engineering, and the idea is, instead of just throwing a simple question at the AI, you carefully craft a more sophisticated prompt that guides its entire thought process, helping it cut through the noise and zero in on the right answer.
This slide is a fantastic example using a technique called chain of thought prompting. Look at the left. With a standard, simple question, the AI gets this basic math problem wrong. It just kind of mushes the numbers together. But now, look at the right. The prompt has been engineered to ask the model to show its work, to think step by step. And just by forcing it to follow that logical path, it easily gets to the correct answer. It's a simple change, but it makes a world of difference in accuracy.
And that really sums it all up, doesn't it? RAG is the bridge. It connects the incredible, almost magical reasoning power of these AI models to real-world, up-to-date, and verifiable information. You get the best of both worlds, that amazing creative intelligence, but now it's grounded in facts.
So RAG has pretty much solved the problem of getting AI to stick to the facts, and that is a massive, massive step forward. But it also leaves us with an even bigger, more interesting question for the future. We've managed to give AI an open book, so what's it going to take to give it the wisdom to actually understand what's in it?